Hello there. An introduction is going to be another new unit. We're going to be diving into a new unit, so we're going to try to cover this entire unit within this packet. So it's going to be a little bit of a long ride, but we're going to make it fun, and we're going to organize our learning along the way in a very concise manner for you to comprehend the entire content as well as the entire unit. That said, let's dive right into it. This unit is going to be called W.E.D. W stands for weathering, E stands for erosion, and D stands for deposition. If you recall, in our last unit, Dynamic Earth, we discussed various layers of the Earth things that are going on inside of the Earth. So we're going to call that Earth's internal processes, and those processes include volcano, earthquakes, seafloor spreading, subduction zone, continental drift. So all of those are the processes that result from the internal layers, the internal things happening inside of the Earth. And as a result of those processes, we have products that are produced from those processes, which are the landforms, including mountains, trenches, islands, rifts, ridges, faults, and we kind of discussed those in depth. So these are internal processes and internal landforms that are created by the internal processes of the Earth. These units, W.E.D, however, they are the external processes, which means these processes are happening on the Earth's surface, outside of the Earth, as opposed to from inside of the Earth. So, which means these processes create different kinds of landforms, but are not coming from inside of the Earth. So, rather, they are happening on the outside of the Earth. All right, we're going to dive a little deeper into these various landforms as we progress. So let's dive into it. Weathering. Weathering simply means the breakdown of rock. When rock breaks down, so you have a large rock produced from a volcano, for example, which is a process from the inside of the Earth, and now you have this rock produced outside. Now, weathering begins to act on it to break down that rock into smaller sizes or smaller particles called sediments. Erosion, on the other hand, moves the sediment, transports the sediments. And the last one, deposition, drops or deposits those sediments in a new environment, in a new place. And all along these various processes and these various rides, different lands or different landforms are produced. All right, again, let's repeat those definitions. Weathering, the breakdown of rocks into sediments. Erosion, the movement of the sediments. Deposition, the dropping of the sediments. So we're going to focus on the first part, which is weathering. Weathering, as we just learned, is the breakdown of rocks into sediments. Now, this can happen either physically or chemically. So weathering is of two kinds. You have the physical weathering as well as the chemical weathering. Physical weathering is when rock breaks down into smaller processes without change in their chemical composition. Chemical weathering, on the other hand, the rock breaks down into smaller pieces by chemical action or chemical reaction. We're going to be organizing our thoughts along the line as we go. So far we've talked about weathering, and we say it's a breakdown of rocks into sediments. And we said weathering can be of two kinds. You have the mechanical or the physical weathering. This is when a rock breaks down into a smaller size without any change in their chemical composition or constituents. Chemical weathering, on the other hand, is when a rock breaks down by chemical reaction. All right, let's take some example of physical weathering. A common example is ice wedging, also known as frost action. Now, this happens when in an area where you have temperatures at freezing temperatures and then melting temperatures as well. So when the weather is warm, for example, water will seep into the cracks of rock, and then when temperature drops, the water freezes, and we know when water freezes, water expands. All right, it's the reason why when we put things in our freezers, they tend to burst or break if it's a bottle, for example. So water expands when it freezes. So when it freezes, it pushes against the wall of the crack, and eventually as it melts and then freezes again, melts and freezes again, season after season, year after year, decade after decade, eventually it splits the rock apart. So we call that frost action or ice wedging. Another kind of physical weathering is extreme temperature. During the day, we get a lot of heat from the sun, and that makes the rock to expand. And at night, when temperatures are dropping, the rock contracts. So day and night, the rock expands and contracts according to the temperature. Season after season, year after year. Over time, the rock begins to exfoliate, which means peels off. The surface of the rock begins to peel off because of that repetition of expansion and contraction. And lastly, you have the biological actions, which means this is coming from living things, from organisms, either plants or animals or even humans. We break down rocks for our construction. Burrowing animals like rats, for example, that would dig a hole into the ground, they break down rocks by continuously digging. And then you have plant roots that can split rocks, like you can see in the picture, into two pieces or smaller pieces as well. So let's wrap that up. Weathering has two kinds: mechanical or physical, and chemical. Common examples of chemical weathering is frost action, when water seeps and freezes and expands and splits the rock apart. Then you have foliation caused by extreme temperature, continuous heating and expansion, and cooling and contraction of the rock over time. And then you have biological action due to the roots of plants or animals or humans. Next is chemical weathering. Chemical weathering, common examples include oxidation, carbonation, hydration, and solution. I understand that could be a lot of vocab words, but we'll break them down one after the other. Chemical weathering is when rock breaks down into pieces by chemical action or chemical reaction. A common example is oxidation. Oxidation simply means the addition of oxygen. All right. It's rusting basically. When you keep something outside in the weather and it begins to rust, that is what it is. It's being oxidized. Oxygen is being added to it. As a result, you often see where oxidation takes place, most of the rocks will be red in color. Next is carbonation. Carbonation happens when carbon dioxide dissolves in water and dissolves in rainwater and creates acidic rain. So as a result of that acidic rain, it can dissolve some rock minerals. A classic example is in a limestone region where you have a lot of limestone, a karst topography. In a karst topography, acidic rain will easily dissolve rocks or dissolve minerals on the ground, creating a cave. Another common example is sinkhole, when a lot of materials or a lot of minerals are dissolved, and over time, when they are dissolved underground, it caves in, creating a sinkhole. Those are common examples of carbonation. And lastly, you have hydration. Hydration simply means the addition of water. When you are dehydrated, you hydrate. All right, you take in water. That's just what it means. So as a result of the intake of water by rocks, they begin to dissolve certain minerals, and those minerals are washed away, creating the rock, making the rock to be weak, and over time the rock begins to break down further. A common example is feldspar, which is easily dissolves out of granite. Okay, and then it turns the feldspar into clay. Another one is solution. It goes side by side with hydration. Solution is just when something solid dissolves completely in water, creating a solution. Okay, that said, here's a common example of oxidation. The Statue of Liberty, as we know currently, it looks like this, but originally it was brown, it was copper, but then it's beginning to rust turning into green, just the way your penny would, as it rusts, you have those blue and those greenish substance coming in. So it's simply oxidizing, which means oxygen is being added to it because of the exposure to the atmosphere. It begins to rust. That's the word. All right. Similarly, with this metal here, is rusting. That is oxidation. When you see a common landform like this and it's mostly red, it's rusting because it has a lot of iron in it, and when you add oxygen to iron, you have that reddish color, and that is what make our planet Mars, one of the planets in our solar system, called the red planet. The surface of Mars is mostly red as a result of oxidation happening to most of the rocks that are rich in iron. So that is what oxidation is: addition of oxygen, aka rusting. Carbonation again is very dominant in a limestone area where acidic rain begins to dissolve the calcite that is found in limestone. So as a result of that dissolution, as a result of that solution being formed, a gap is created, a cave is created. That opening, that gap, is what you call a cave. And oftentimes you see those funny pointing things from the roof, and some pointing from the ground. Those coming from the roof, they are called stalactite, and those coming from the ground are called stalagmite. All right, stalactite, very similar to saying satellite, which means coming from up, is coming from the roof of the cave, and stalagmite from the bottom of the cave. When a stalactite and a stalagmite meet, you have a pillar. All right, that's carbonation. All right, here's a summary of everything we've learned so far. Weathering, breaking down of rock into smaller pieces. There are two kinds of weathering: physical or mechanical weathering, and chemical weathering. Physical weathering include frost action, exfoliation or extreme temperature, biological action of plants or animals or humans. While chemical, you have oxidation or rusting, carbonation, hydration, and solution. All right. This graph here, or this table here, tends to show the area or different parts of Earth where chemical weathering would dominate, or where physical weathering would dominate. As we spoke about physical weathering, especially frost action, you're going to need a lot of low temperature to freeze that water. So whenever you have temperature ranging below freezing temperature, which is 0 degrees Celsius, then you will see that physical weathering will be dominant in that part of the earth. And usually those part of the earth, they receive very little amounts of rainfall. So on the x-axis, you have precipitation, which is another way of saying rainfall. And then you have annual temperature, how hot the weather is, on the y-axis. So if the temperatures are hot, which means above 0 degrees, then you see that chemical weathering will be very dominant in that part of the earth, because you need temperature to carry out reactions, chemical reactions. However, for frost action to be in charge, or for frost action to dominate, then you need cool temperatures and around below 10 degrees Celsius, and there with little rainfall. All right. And I think that would be the end of part 1 for us. As usual, we would review some recent questions, and we'll wrap it up right there. Okay, so let's practice with this question here. Question number 1, base your answer to the following question on the graph below, which shows the effects of average annual precipitation and temperature have on the type of weathering that will occur in a particular region. And the main question here says, which type of weathering is most common where the average annual temperature is 5 degrees Celsius and average yearly precipitation is 45 cm? Okay, we just have to find those little values there using what the question provided for us. Okay, let's take a pen here, and the question here says 5 degrees temperature. So I can see temperature here is on my x-axis. So I'll look for 5 degrees and I'll follow that up. and it says 45 degrees cm for precipitation, which is rainfall. So rainfall is on my x-axis here. I'm looking for 45. This is 0, this is 25, this is 50. So 45 probably would be something close to that area, so I'll follow through. So if I follow my 5 degrees Celsius, both of them would meet here, and in this area it is slight frost action that will be dominant in this part of the earth where temperatures are around 5 degrees Celsius and the amount of rainfall is around 45 cm. So the correct option here would be very slight weathering, no, slight frost action right here. Option D, slight frost action. That would be our answer because that was what we got from the graph. All right, let's move on to question number 2. The diagram below shows granite bedrock with cracks. Water has seeped into the crack and frozen. The arrows represent the direction in which the crack have widened due to weathering. Which statement best describes the physical weathering shown by this diagram? Option A says the enlargement of cracks occurs because water expands when it freezes. Yeah, we did discuss that. So option A probably will be our answer. Let's look at option B. This type of weathering occurs only in bedrock composed of granite. It can occur anywhere, depending whether it's granite or basalt or conglomerate. Frost action can break down anything. It can even break bottles in our refrigerators. So it has nothing to do with granite. Option C, the crack becomes wider because the chemical reaction between water and the rock. No, there's no chemical reaction here. Option D, this type of weathering is common in region of primary warm and humid climate. If it's warm climate, the water will not be frozen. So we actually need a frosty environment where temperatures are very low to freeze the water. So option D would be wrong as well. So yeah, our correct answer definitely there is A. Question number 3. The diagram below shows the stump of a tree whose root grew into smaller cracks in the bedrock and split the rock apart. The action of this root splitting the rock is an example of chemical weathering? No. Deposition? No. Erosion? No. Erosion is the movement of sediment. Deposition is the dropping of sediment. Chemical weathering is as a result of reaction. There's no reaction here. It is physical. You're just splitting the rock into two without changing its chemical composition. So our correct answer here would be physical weathering, option D. Question number 4. The 2-block diagram below represents the formation of cave. Which type of weathering and erosion are primarily responsible for the formation of caves? Right, we discussed cave, and we say caves are very common in limestone. So I see the limestone there, and it was developing here a little, and now it's more developed and pronounced here. And we did say it happens on the ground. So both sinkhole and caves are on the ground. So option A says chemical weathering and underground water flow. Yeah, it does look like A to me. B says chemical weathering and runoff. Runoff only happens on the surface. So for a cave to occur, it has to be underground. Yeah, so it cannot be a runoff. Physical weathering, no. Physical weathering, no. So yeah, our option is A. We good. Question number 5. And then question number 5 says, which substance is represented by X on both sides of the flow chart? So I see substance X here, and I see substance X here. And it says weathering. Weathering has 2 kinds. Then this type is caused by expansion of substance X. Frost action breaks up the rock caused by the expansion of substance X. Yeah, we talked about frost action. Definitely it's water that freezes and expands and breaks the rock. So it does look like water to me. Here it says another type, A, involves substance X again, which combines with the atmospheric gases. Yeah, it is water. It is rainwater that combines with carbon dioxide in the atmosphere to create the acidic rain, which causes carbonation or which can cause hydrolysis. So correct option here definitely would be option D, water. And that is it. That's a wrap. I'll see you in part 2. Bye for now.